In this video, we'll learn about linear change. So a linear function's output values increase or decrease by a constant amount when the input values increase by 1. All right, so what does that mean? The example will illustrate what we're talking about. So if Amanda makes $10.50 per hour at her job, write her weekly salary, S, as a function of hours worked, N. So what this means is we need to come up with a formula for her weekly salary based on how many hours she works. Well, it's clear that her weekly salary can be computed by multiplying her hourly wage by the number of hours that she works. And when we do that, we'll come up with a formula, S equals $10.50 times the number of hours she works, which is N. So this is S written as a function of N. This is an example of linear change, and we'll see why it got the name of linear on the next slide. Continuing the previous example, if Amanda works 1 hour in a given week, she'll get paid for 1 hour, which is $10.50. But if she works 2 hours, she'll be paid for an additional hour. So to go to the next line here in this table, we'll add an additional $10.50. And she'll get paid $21. But if she works 3 hours, then we can add an additional $10.50. And she'll get $31.50. Now with each additional hour, we'll add $10.50. So this is an example of linear growth. After 4 hours, she'll have $42, and with 5 hours, she'll get $52.50, and with 6 hours, she'll get $63. Now we can treat each of these rows as an ordered pair and graph them on the plane. So, for example, for 1 hour worked, she made $10.50. If she works 2 hours, she'll make $21. And I'm just going to carefully graph each one of these. So after 3 hours, she makes $31.50. Of course, I'm just estimating the height. After 4 hours, she makes $42. After 5 hours, she makes $52.50. And we see that a nice pattern is developing. After 6 hours, she makes $63. And we have this nice graph of a line. So this is an example of linear growth. We'll always recognize a graph of linear growth. We'll have a straight line that goes up as we move from left to right. Linear decay, on the other hand, is going to go down as we move from left to right, but it will still be a straight line. Let's check for understanding. Pause the video and work this one out on your own, and then come back and double check your answer. An electrician has 540 outlets to install in a new building and can install 60 outlets per day. Fill in the following table with how many outlets he has left to install at the beginning of each day. So we know that at the beginning of day 1, the electrician has 540 outlets to install. After installing 60 the first day, we need to remove 60 from that amount. And so we'll subtract 60, obtaining 480 at the beginning of the second day. And then we'll remove another 60, which will give us 420 at the beginning of the third day. And again, remove another 60, which gives us 360 at the beginning of day 4. And then we'll be down to 300 when we remove our final 60 before day 5. This is linear change, because we're adding or subtracting the same amount each time, but it's also going to be decay because the amount is decreasing. We're subtracting the same amount each time.